Welcome to the second part of the collection view series tutorial. In this part, we are going to continue from what we left on in the first part. In this part, we are going to implement collection view into a view controller and set up and configure the collection view flow layout as well as the UI collection view data source. And we're going to implement self-sizing cell and headers so we can adapt for the thread collection changes, both for the text changes as well as the orientation changes. So, without further ado, let's continue on the second part of the tutorial. To begin, we will create a view controller that will render a collection view with single section. Inside the view controller here, create a new file, cockatouch class, set it as subclass of UI view controller, give it a name of single section characters view controller. Make sure to uncheck the also create xib file. Let's remove this. Inside the class, declare a private constant named UICollectionView. Initialize it with UICollectionView. Let's pass 0 as the frame. And for the collection view layout, let's initialize it with UICollectionView flow layout. Next, declare the private property named characters and assign it with the default value of universe ff7r.stubs. And also add a didSet property observer and just invoke collection view reload data. We are gonna use SwiftUI view controller representable to preview this view controller. So let's import SwiftUI here. And below the class declaration, declare a new struct named single section characters view controller representable. Make it conforms to UI view controller representable. There are two required methods that we need to implement. First is the make UI view controller context. Here, replace this return type. We just return a UI view controller. Here, I want to return a UI navigation controller. And for the root view controller, I'm going to initialize the single section characters view controller. Okay. And for the other required method, update UI view controller, let it empty. Now for the previews, declare a new struct again, single section characters view controller underscore previews. Make it conforms to the preview provider and implement the required preview static property. Here we just need to declare the single section characters view controller representable. Also add additional modifier edges ignoring safe area passing top. This will ignore the safe area instance for the navigation bar. Try to build here, make sure there is no error. And let's enable the canvas. Okay, click on resume. Okay, the live preview for the view controller is rendered here. Now we can move to implement the view controller. Okay, so let's move on to set up the collection view in the view controller. Declare the setup collection view private method. Inside the method, set the frame of the collection view with the view bounds to match the size of the view controller view. Then assign the background color as system background. With this, the background will automatically adjust the dark and light appearance set by the user from the settings. The background will be white for light and black for dark. Then set the collection view's auto-resizing mask with array containing flexible width and flexible height resizing mask. With the auto-resizing mask, the collection view will automatically adjust the size of its view to match the view controller view. Next, set the delegate and data source of collection view as self. Just ignore the UICollectionViewDataSource conformance error for now. We are going to conform to the protocols later. Register the character cell class passing cell as the cell reduce identifier. And next, register the header view for supplementary view of kind, passing the UI collection view element kind section header. For the identifier, let's pass a hard-coded string header. Finally, we need to add the collection view as the subview of the view controller view. Let's add this invocation inside the view did load. Declare an extension for the single section characters view controller. Let's conform to the UI collection view data source protocol, as well as the UI collection view delegate flow layout. By conforming to the UI collection delegate flow layout, we also conform to the UI collection view delegate. Now let's implement the required methods. First is the collection view number of items in section. In this method, let's just return the characters count. As we are only using a single section, we are not overriding the number of sections in collection view. The default number of section is 1. The second required method for the UI collection view data source is cell for item at index path. In the body, let's declare a console named cell and then invoke the collection view, the queue, reusable cell with reuse identifier. We can pass cell and then pass the index path. And we can just pass this to character cell. Because we already know that this identifier is registered with the character cell. Here we can just return cell. To retrieve the character, we can retrieve it from the array, passing the index path.item to the subscript, and we can invoke cell setup, passing the character. There's one additional method that we need to implement to render the header view, which is the collection view for supplementary element of kind at index path. Here we can just retrieve the header view using the collection view, the queue, reusable supplementary view. For the kind, we can pass UI collection view element kind section header with reuse identifier of header or index path. We can also cast this to header view. Because we register the header view with the header reuse identifier for the supplementary header view. Let's set up the header view text. Here we can just pass characters, and using the string interpolation, let's use the characters that count to display the number of characters. Okay, so next we just need to return this header view. That's it for the implementation of UI collection view data source. Next, we are going to set up the flow layout. There are two approaches to set up the item size and the header size for the flow layout. First, we can override a method in the UI collection view delegate flow layout. It's called collection view layout size for item at index path and collection view layout reference size for header in section. Those methods will be invoked for every index path and section header. The second action is much simpler. We can just set the flow layout's item size and reference header size. We are going to use the second approach. So let's delete this and declare a private method here named setup layout. Using the guard statement, we need to get the flow layout from the collection view layout property. Collection view layout, and we need just to pass this to UI collection view flow layout. If it fails, we just return. Let's add a section inset for each section in the flow layout. Flow layout, you can use flow layout section inset and assign it with UIH inset. For the top, we can just pass 0, and for left and right, let's pass 8, and for bottom, let's also pass 0. Next, we need to set the minimum line spacing and minimum inter-item spacing as 0. We don't need this spacing because the character cell itself has already provided its own internal padding. Before we implement the self-sizing cell and header, let's set the item size using a fixed size. We will see why this approach doesn't provide a good accessibility to the user and does not scale. For the item size, set it with the CG size with width of 120 and height of 150. For the reference header reference size, let's set the width to 0 and pass the height as 40. The flow layout will ignore the width and use the width of the collection view. So the value of the width in the header reference size doesn't matter. Next, we need to invoke this in vDidLoad. Let's add this after the invocation to set up collection view. Setup layout. Okay, now let's try to build and run the live preview again. The cells and headers are rendered successfully. But if you see closely, you can see that the header view text label is getting truncated. To make it worse, let me set a large text size using the environment modifier here. I can use size category, passing content size category of accessibility extra large here. If you see now, all the cells labels are getting truncated. So we can see from here using a fixed width and height for the cell and header view does not scale. And it is very bad for the accessibility. We're going to solve this problem by using a self-sizing cell and header. Implementing self-sizing collection view cell is not as straightforward like implementing table view cell with dynamic heights. In table view cell, the width of the cell is the same as the width of the table view bounds. On the other hand, the collection view gives the responsibility of how the layout should be rendered to the collection view layout. In our case, the flow layout. This means, in addition of setting the auto layout constraints for all the child views in relation to the cell, we also need to constrain the width or the height of the cell itself. If we constrain the width, the height will be dynamic. Vice versa, if we constrain the height, the width will be dynamic. In the case of character cell, we will constrain the width of the cell itself based on the width of the current size class track collection. For every icon in portrait, the horizontal size class is compact, and the vertical size class is regular, while for iPhone passes 10x Max, 11 Pro Max in landscape, the horizontal size class is regular and the vertical size class is compact. When the horizontal size class is compact, we show 4 cells in a single line. When the horizontal size class is regular, we show 8 cells. Okay, I think that covers the basic. Let's navigate to the character cell for the implementation. There are many ways to implement the self-sizing cell. We can constrain the cell width or height anchor in the setup layout. Another way is to override the system layout size fitting target size with horizontal fitting priority and vertical fitting priority. I prefer to use the second approach as I think it's more clean and encapsulated. Let's override the method. System layout size fitting with horizontal fitting and vertical fitting priority. In the implementation, declare the padding constant as 8 with type of CG float. Then declare the number of items constant. Here we can access the thread collection, horizontal size class, check whether it is compact, and using the ternary operator, set it as 4. It is compact and 8. Next, we need to calculate the item width. So declare the constant and retrieve the screen width using UI screen main bounds.width. And we also need to subtract both the leading and trailing section insets padding using padding multiply by 2. And we need to divide the result of this using the number of items. Let's cast this to CG float first. Okay. And as the result will be in fraction, let's run it down by using floor function. Finally, we need to return the target size by calling the super system layout size fitting. For the target size, let's initialize CG size. For the width, let's pass the item width. And for the height, let's pass UI view their layout fitting expanded size the height. This will tell the system that the height will be dynamic. And for the horizontal fitting priority, because the width is fixed with the value of item width, let's pass required select priority. And for the vertical fitting priority, you need to pass fitting size level. So UIKit will calculate the height based on the auto layout constraints. That's basically it for the implementation of self-sizing cell inside the character cell. Now let's navigate back to the view controller here. Single section character view controller and navigate to the setup layout. Here we just need to remove the item size here. And then we can use the flow layout estimated item size, assigning UI collection view flow layout dot automatic size. This will tell the flow layout to calculate the cell based on the auto layout constraints. Okay, so let's now try to build and run the live preview. Nice. Now the cell is not getting truncated here from the top and bottom. Now let's just change the accessibility here. Let's change the content size category to medium. Let's try extra large here and extra large. Nice. So we can see now the cell is resized properly even if we change the text size. Sadly, as of now, we cannot change the orientation in the preview. So we need to test the orientation change to landscape directly from the simulator. Okay, so now let's navigate to the scene delegate.swift file and replace this UI view controller with single section collectors view controller. Make sure to select a large size iPhone. In this case, I'm using iPhone 11 Pro Max and run it in the simulator. Okay, now we see the collection view in the simulator. To rotate, we can just click here, the rotate icon. Nice. Now the collection view render 8 items per line in the landscape direction. Now I'm going to test the accessibility. Let me go to settings, accessibility, display and text sizes, larger text. I'm going to turn this on and set it to the maximum text size. Okay, we can see that here the cells is not getting resized correctly after we change the text size in the settings. So we need to handle this. Basically, we just need to go to the view controller here, and there is one method that we need to override, which is trait collection the change. This method will be invoked whenever a trait collection change. For example, when the device is rotated or when the text size changes. Let's just invoke super here, collection with change. And to update the collection view layout, we can just use collection view collection view layout dot invalidate layout. Okay, so let's build and run again. You can see now it is rendered properly. Let's change the text size again from settings here. Going back here, going back to the app. Nice. The cells are resized properly. Let's go change it again to large. Okay, nice. So our cells are now resized properly whenever we change the text size from the settings. Let's move on to fix the height of the header by using dynamic height. The flow layout itself does not provide an API to automatically estimate the size of the header based on the auto layout constraints. What we can do to handle this is to override the collection view layout reference size for header in section. Let's override it here. Collection view layout reference size for header. Okay. We cannot invoke the collection view supplementary kind of index path, as it will dequeue the header again, causing duplicate header view. To solve this, we can just initialize a header view. We won't be rendering this. We are using this just to calculate the size. And we also need to set up the text label with the content. Let's just use this. Then for the return, we can invoke header view system layout size fitting here. For the target size, we can initialize a CG size here. Let's use the collection view dot bounds done with. And for the height, let's pass UI view layout fitting expanded size height, as the height will be dynamic depending on the content. And for the horizontal fitting property, the width is fixed, so let's just use required. And for the vertical fitting priority, let's pass fitting size level to make UIKit calculate the height based on the auto layout constraints. And then next, we need to remove the code here in the setup layout that sets the header font size with a fixed value. Now let's try to build again. Okay, now we can see that the header view height is calculated properly and it's not getting truncated anymore. Let's test it by change this to extra large, triple XL. Nice. Now all the supplementary view and the cells are resized correctly. Let me just remove this. Next, let's move on to handle data source update for the collection view. First, we're gonna add a segmented picker at the top where the user can tap on one of the segments to update the universe. Inside the single section view controller, declare a private method named setupSegmentedControl. And let's declare the segmented control and store it as a property using let. So we just need to declare a property for the segmented controller here. Segmented control. And initialize it with UI segmented control. We need to pass the items here. And we will pass an array of string. We're going to use universe, all cases, which we can get because universe conforms to the case iterable. This will return all the cases. We just need to map this and use the title property for each case. Okay, now we have the segmented control. Before we implement the setup segmented control, let's create a method using the objc keyword and give it a name of segment changed. Accepts a single parameter sender with type of UI segmented control. Okay. We can just assign the characters using the extension of US segmented control to access the universe based on the selected segment index and the stops. Okay. For the setup segmented control, let's set the default selected segment index to 0. Okay. And we also need to add the target action selector, segmented control at target. Target will be self, action will be the selector, segment changed. And for the event, we can use value changed. We also need to set the navigation item title view with the segmented control. Okay, now let's invoke this in the VDate load before the invocation to set up collection view. Set up segment control. Let's try to build and run the live preview. Okay, now we have the segmented control. To enable interaction, you must press this arrow button. Okay, now let's change to another universe. Nice. Okay, before we move on, I want to show you something. Here I have the app run on the simulator. If I open the console here, I can see there are many warning messages about the breaking constraints. It doesn't really affect the app, but we can do better, right? We can remove all of this warning. It's mentioning about the layout height. It's conflicting with our constraint in the height, which is the rounded image view here. If you see the height. So basically to solve this, we can go to the character cell and let's put this in a constant here. Give it a name of height constraint, image height constraint. And what we can do to fix it is to set the priority here. Set the priority using a raw value here. And we're going to give it a high priority, which is 999. And let's edit here. Okay. Let's try to run again. So there's no error for this. No more error in the console. And we also need to do this for the header view actually. So let me navigate to the header view. We also need to handle it for the leading and the bottom anchor in this case. So let's put it in the constant here. Let's say leading. No, I'm not. I want to use the trailing one. Let's assign the trailing constraint. Set the priority to UL priority. Initializer with raw value 999. Let's do the same for the bottom anchor. To run again and test. Okay, that's it for this part 2. In the next part, we are going to learn about the collection view perform batch updates API, where we can update, insert, and move sections and index paths in one single transaction.